Hello viewers, in today's session we are going to discuss another conceptual problem from derivatives, and here we are going to solve this problem where we are given a function y that is equal to sine inverse 1 minus x square over 1 plus x square, where x belongs to the interval that is the open interval 0 comma 1, and we have to find the derivative of y with respect to x at x is equal to 1 over square root of 2, right? So let us see how we can find out the derivative of this function y at this point using the concept of inverse trigonometric functions. So let us start. So here the first step is to make this substitution, that is x is equal to say tan theta. So we are making this substitution because we know that 1 minus tan square theta divided by 1 plus tan square theta is given by cosine 2 theta. So the double angle formula for cosine function, that is cos 2 theta, is given by 1 minus tan square theta over 1 plus tan square theta. So when we take x is equal to tan theta here, this function y, it takes the form y is equal to sine inverse 1 minus tan square theta divided by 1 plus tan square theta, and this expression can be replaced by cosine 2 theta. So we have now sine inverse and cosine 2 theta. So now this is an important expression, right? And here we are given this condition, that is x belongs to the interval 0 comma 1, that is x is greater than 0 but less than 1. So now to move further, let us make use of an important property of inverse trigonometric functions, that is the sine inverse of say sine alpha is equal to alpha, provided this alpha belongs to this interval, that is minus pi by 2 to pi by 2, right? So here we have minus pi by 2, and here we have pi by 2, and if we take the value of the approximate value of pi, then minus pi by 2 is approximately minus 1.57, and here we have plus 1.57. So sine inverse of sine alpha is equal to alpha, where alpha belongs to this interval, and here this expression is similar to this one, but here we have cosine 2 theta and here we have sine alpha, right? So the first step is to convert this cosine function into a sine function, right? So here we'll make use of an important identity from trigonometry, that is sine pi by 2 minus x is equal to cosine x, right? So now we can write y is equal to sine inverse, and here we have cos of 2 theta. So cos of 2 theta can be written as sine, and here we have pi by 2 minus 2 theta. So here we have taken 2 theta for x, right? So sine pi by 2 minus x is equal to cosine x, so that sine pi by 2 minus 2 theta is equal to cosine 2 theta. So replacing cosine 2 theta by sine pi by 2 minus 2 theta. So now here we have the sine function. Now the value of alpha is given by this expression, that is pi by 2 minus 2 theta. So now the value of alpha, that is pi by 2 minus 2 theta, must belong to this interval, that is minus pi by 2 to pi by 2, because then only we can write here sine inverse of sine pi by 2 minus 2 theta as pi by 2 minus 2 theta, because we can write this expression as sine inverse, and here we have sine alpha, right? And sine inverse sine alpha is equal to that is alpha when this alpha, that is pi by 2 minus 2 theta, belongs to this interval. So let us first verify that this alpha, that is pi by 2 minus 2 theta, is it lies in this interval. So we'll make use of this inequality, that is the given condition. So here we are given that x is greater than 0 but less than 1. Now x is tan of theta, so we can now write here tan theta, and here we have 1, right? So now when tan theta is greater than 0 but less than 1, then theta belongs to the interval, that is 0 to pi by 4. So taking the tan inverse of these three quantities, here we have 0, and then here we have simply theta, and tan inverse of 1 is pi by 4. So when tangent theta lies between 0 and 1, then theta lies between 0 and pi by 4. So now here we have 2 theta. So let us multiply this inequality throughout by 2. So here we have 0, here we have 2 theta, and here we have pi by 2. So here cancelling this 4 by 2. So now we have 2 theta, it belongs to this interval 0 to pi by 2. So now here we have a negative of 2 theta. So let us multiply throughout this inequality by minus 1. So here we have 0, here we have minus 2 theta, and here we have minus pi by 2. And when we multiply an inequality by a negative number, the direction of the inequality gets reversed, right? So now we have this inequality, which can also be written as minus pi by 2 is less than minus 2 theta. This is further less than 0. So now here we have pi by 2 minus 2 theta. So let us add pi by 2 throughout this inequality. So we have now here pi by 2, and here we have minus pi by 2. So adding pi by 2 throughout, we have here pi by 2 minus 2 theta, and then we have 0 plus pi by 2. So here these two terms get cancelled. So we have 0. Here we have pi by 2 minus 2 theta, and here we have 0 plus pi by 2, that is pi by 2. So we have now pi by 2 minus 2 theta is alpha. So here we have pi by 2. So now alpha lies in the interval, that is 0 to pi by 2. So here we have 0 in between minus pi by 2 and pi by 2. And from this inequality, we see that alpha belongs to this interval, that is 0 to pi by 2, right? And it is verified that alpha belongs to this interval. So we have seen that pi by 2 minus 2 theta, that is our alpha, it belongs to this interval, that is minus pi by 2 to pi by 2, and 0 to pi by 2 is a subset of this interval, right? So we have verified that this expression pi by 2 minus 2 theta belongs to this interval. So now we can write sine inverse of sine pi by 2 minus 2 theta as pi by 2 minus 2 theta due to this property. So now from this expression x is equal to tan theta, we can write theta is equal to tan inverse of x. So substituting for theta as tan inverse x, we have y is equal to pi by 2 minus tan inverse x, and here we have 2. So now we can differentiate both sides with respect to x. So dy over dx is equal to the derivative of pi by 2 is 0, being a constant, and here the derivative of tan inverse x is 1 over 1 plus x square. So this is minus 2 over 1 plus x square. So the derivative dy over dx of this function is equal to minus 2 divided by 1 plus x square, and here we have used this result, that is the derivative of tan inverse x is 1 over 1 plus x square. So now we have to find the derivative at this point. So let us substitute x is equal to 1 over root 2 in this expression. So we have minus 2, 1 plus 1 over root 2 square. So we have minus 2 over 1 plus half. Root 2 times root 2 is 2. So we can now have here minus 2 and 1 plus 3, 1 plus half is 3 over 2. So we have here minus 4 over 3. So they taking this 2 to the numerator. So we have minus 4 over 3. So the value of dy over dx at x is equal to 1 over root 2 is given by minus 4 over 3.